Assalamualaikum everyone. This is me, Rizanat Nazia, a 10th grader student from Munna International School and College. And after 1 year, I'm uploading this video on my YouTube channel. So in this video, we're gonna learn the equations of motion which we have in our 9 or 10 classes there in the chapter number 2, motion chapter, and we'll learn the equations of motion, their derivation, and also what do they mean, the meaning of these equations. So yeah, let's get started. Okay, so first of all, I want to tell you that I hope that you know the terms V, U, A, T. You know these meanings. Like, I have written those. U means initial velocity, V means final velocity, A means acceleration, which is actually, here we say uniform acceleration. Then S is meaning distance or displacement. Okay, so if we hear distance or displacement as, we'll use the term S, because in our book or in our mathematics, what we do in class 9 or 10, there we see a linear path. A car, a man, a ball, anything is passing through a linear line. That's why, as this is a linear path, so displacement and distance are equal. You know, right? You know the term distance or displacement. I hope that, because this video is all about the equations of motion. Okay, so that's why whether it's a distance or displacement, we'll use the letter S. And T, obviously we know it means time. Okay, so everything is clear. So we're gonna start with the first one, which is V is equals to U plus AT. Okay, I'll write here V is equals to U plus AT. Okay, fine. So what does this equation mean? The equation is actually about velocity, which is the final velocity, the V. So this equation tells us if we have the value initial velocity, acceleration, and the time. That means, let's say it's a car and the car is moving from here to here. So here it will have the initial velocity, which is U. Here it will have V, the final velocity, and the time to pass this path is the T. So if you have, and the acceleration it's moving with is A. So if you have the initial, the time, and the acceleration, then we can find out the V. Now you might be thinking, how this equation came, right? Like, how do we get this equation? Okay, let me tell you. Okay, so this equation is basically from the concept of acceleration. What is acceleration? Tell me. What do you know? That acceleration meaning is that the rate of change of velocity with time or relative to time. That means how the velocity is changing with the time is known as acceleration. So what do you know? A is equals to V minus U by T, right? Why V minus U? You know that the rate of change of velocity. So how you will know? Like here, the initial velocity is 1 and here the final velocity is 5. So what's the rate of change? What's the change here? We know it has increased 4, right? Here 1, here 5 meter per second. So it has changed 4. It has a difference of 4. Thus, how do we get this 4? We subtract 1 from 5. That's how we get 4. That means V minus U, which is this. V minus U divided by T, because obviously we need time, right? Because the velocity is changing according to the time. The time is increasing, the velocity is changing. And that's the fact of acceleration. Great. So you know, we have got this equation from the concept of acceleration. Now derive it. Such an easy equation. Now let's do cross multiplication. So A is multiplied with T, which is 80 is equals to V minus U. And in the formula we need what? We need V. So V here. So V equals to, here U is minus. So here it will be plus, and 80 is already plus. So U plus 80. Yeah, that's the equation. That's the first equation of motion. And we have get it from the concept of acceleration. Okay, so the second equation. The second equation is S is equals to, S means displacement slash distance, equals to ut plus half at squared. So what is this equation telling us? This equation is telling us that an object or a car, so this car is traveling from here to here and it's covering a distance which is S, and the distance it's covering is equals to ut plus half at squared. That means we don't need this v or velocity for finding out the distance. So if we don't have the velocity, then we can easily find out the distance. And what is the derivation of this equation? Okay, let's see. So before showing that, I want to tell you something, which is, we know that v is velocity, that means the final velocity, right? But vw, for like identifying, it's not here in the book, but for identifying vw is like average velocity. So average velocity is equals to u plus v divided by 2. Okay, you'll think for a second, wait, is there any formula or how did I get this? Wait a second, this is a normal equation. How do you get an average? Like we sum up the numbers that divided by the counting numbers, right? So that's what we did. Like u plus v, the total v, divided by 2, as there are two quantities. So yeah, that's how we get it. So this is the average velocity. By using this and another one, which is, we know that for distance we have another one which is s equals to vt, and this v is for uniform velocity. So here we can also get, so using this equation, using these two equations, we'll see the derivation of this equation. Okay, so let's write that v is equals to u plus v divided by 2. Okay, hold on. What do you know about this v? We have already found an equation which is v is equals to u plus at. So for this v, we can write this equation. So let's write 2u plus v is equals to u plus at. Right? Yeah, as simple as that. So if we like sum up, here is 2u. So 2u plus 80 equals divided by 2, right? And if we like break it, then we'll see here 2 will deduce it, then it will be u, and then 2 in the below, and here we have 80. So 80 divided by 2, we can write simply plus half 80. Have you understood this? Like we are separating 2u here and then 80 divided by 2 here, just like this. So 2 deducing, so u plus 80 divided by 2, which we can also write as half 80, right? Okay, great. Okay, now what we'll do is, we'll take up this. So S is equals to Vt. Yeah, we know that for uniform velocity, right? Okay, now instead of this V, we'll write this one. U plus half 80. What we have got from these lines. So we'll write u plus 80 without writing the v. So instead of v, we'll write u plus half 80 and multiplied with t, which is u multiplied with t is ut plus half into t into a into t. So there are 2t, so t into t equals to t squared. Yeah, so half 80 squared. And similar? Right, these are similars. So this is the answer. So that's how we get the second equation. And it's super easy because we just need two equations for that. Number one is the average velocity, which is, we know, the simple mathematical term to find out the average of anything. And then the second one, which is S is equals to Vt, which is for the uniform velocity where we have distance and time. So yeah, that's how after from this average velocity, we'll get equations like this, and we'll put the velocities formula from the equation number 1, and we'll get this line where we'll find u plus half 80, and then u plus half 80 is equals to v, where this value is going to put up here, and we'll get a result half 80 squared ut plus half 80 squared is equals to s. So equation number 2 done. Great. The third one is v squared is equals to u squared plus 2as. Okay, what is this equation telling us? This equation telling us that we can find v, that means the velocity, the square of velocity from the square of initial velocity, adding with 2 times of the acceleration and the distance. So you might be thinking that there is missing time. That means if we don't know the time of a car from moving here to here, if we don't know the time, then it's totally fine. We can get the velocity if we have these 3 things, get the distance or the other from like solving the equation step by step. Okay, so let's see how this equation has derived. Okay, first of all, we remember the first equation, don't you? Okay, look at this. V is equals to u plus 80. So we'll write this. V is equals to u plus 80, right? But is there V? Is there u? Is there time? No. So what we need to do? First of all, we'll square the both sides. Fine, great. Second step, after we squaring up this square, we'll make the equation derived through the formula of a plus b whole square. Let's think, this is a, this is b. So a plus b whole square. What's a plus b whole square? It's a square plus 2ab plus b square. We have know that. Okay, so let's do u plus 80. So a square plus b square. A square plus a plus b whole square equals to, a plus b whole square equals to a square plus 2a, b is 80, plus b square, that means a square t square. Right? Okay, great. Now what we'll do is we'll take common, and we don't need to take u as the common, but we'll take here a. There's a, but we'll take 2a. So see, 2a we're taking common from this line, and so 2a from here, so it's ut, 2a cross, so you get ut plus, okay, my plus and the t's are looking similar, so I'm just extending their legs. What do you think? Great? Okay, great. So ut, and then For taking here 2a, we have a, so we can here use a. So a into a is a squared. But where is the 2? How can we take 2 as the common? Well, it's pretty much so easy. We'll take a divided by 2 and t is here, so t squared. Yeah, because if we multiply this with this, then 2 minus a squared t squared, which is this, a squared t squared. So yeah, now let's look at this line. Ut plus et squared divided by 2, or ut plus half 1 by 2 half et squared. Hey, is there any formula for that? Yes, of course. This is number 2, which have is equals to ut plus half et squared. So this actually means s. So if we write u squared plus 2a, instead of the whole line, if we write s, so s, so b squared, the answer? Yes, b squared equals to u squared plus 2as. And that's the answer and the derivation of the 3 equations. So let us remind. Okay, so for the first one, we needed the concept of acceleration. The rate of change of velocity according to time is acceleration. From that one, we have got v is equals to u plus at. The second one, we have got the second one from 2 terms. Number 1 term is the average velocity is equals to u plus v divided by 2. And from there we have put it the v is equals to u plus at, right? Then we have got the average velocity result as ut plus half at. And then s is equals to, we know that s equals to vt for the uniform velocity. And from there we got the another t for t squared and t here, and we got the result. For number 3, we didn't need anything. We just need to put the square in the first equation, and then we got some value. We did take common, and from the taking of common, we have received equation, which is basically the equation number 2 of motion. And then after rearranging, we have got v square is equals to u square plus 2as. And that's the concept, derivation, the equations meaning, and all about 3 laws of motion or equations of motion. Hey everybody, I hope that you have liked this video and understood every part of the video. And if you have any thoughts on this video, you can comment down below. And I hope that you have understood the 3 laws of motion, their derivation fully. And yeah, that's it for the video. Please like, comment, share this video, and we'll see you guys next time. So, ta-da!